September 27, 1941. Richmond, California. Henry J. Kaiser stood in an empty field that would become the largest shipyard complex in human history. The impossible contract sat in his pocket. Build 60 cargo ships when America had barely constructed 23 vessels in the entire previous decade. Every maritime expert in the country had told him the same thing. It couldn't be done. The mathematics of desperation told a different story. German U-boats were sinking Allied merchant ships faster than Britain could replace them. One vessel every 4 hours in the North Atlantic. England would starve in 6 months without a miracle of industrial production. Kaiser had never built a ship in his life, but he'd finished the Hoover Dam 2 years ahead of schedule, and he understood something the shipbuilding establishment didn't. That impossibility was just a failure of imagination. In 18 months, his workers would prove him right by launching more tonnage than the entire British merchant fleet lost in 1940. By war's end, they'd build vessels so fast that German submarine commanders would report home in defeated disbelief. The old guard dismissed him as a dam builder, playing with toys he didn't understand. Traditional shipyards took 6 to 8 months to construct a single cargo vessel using methods refined over centuries. Skilled riveters required 6 months of training, and there weren't enough of them in the entire country to meet wartime demand. The U.S. Maritime Commission had calculated America's maximum production capacity, maybe 200 ships per year if every yard ran at peak efficiency. Kaiser looked at those numbers and saw them as insults to American industrial capacity. He saw assembly lines, modular construction, and manufacturing techniques that could transform shipbuilding from a craft into an industry. November 1940. London, England. The British Purchasing Commission arrived in Washington with an emergency request: 60 cargo ships based on their simple ocean-class design. Nothing fancy, nothing fast, just utilitarian freighters that could carry 10,000 tons of cargo across submarine-infested waters. The design dated to 1879, coal-fired boilers, technically obsolete triple-expansion reciprocating engines, riveted steel construction. It was deliberately primitive because Britain needed quantity over quality, and they needed it immediately. Every month, German U-boats were sinking 150,000 tons of British merchant shipping. At that rate, Britain's merchant marine would be destroyed within 2 years. The mathematics were existential. Build ships or lose the war. American shipyards reviewed the specifications with barely concealed contempt. The ships would be slow, 11 knots maximum, making them sitting ducks for U-boat wolf packs that could make 17 knots surfaced. The steel requirements exceeded anything produced domestically in those specifications. The riveting alone would consume labor resources that didn't exist. Todd Shipyards in Maine took the first contract, promising delivery in 8 months per vessel. 8 months multiplied by 60 ships equaled 40 years of continuous production. By that timeline, the war would be over, one way or another, before the first dozen ships sailed. The British diplomats returned to London with contracts, but little optimism. Kaiser saw something else in those specifications. The simplicity wasn't a weakness, it was an opportunity. While traditional shipbuilders saw a vessel that required 600,000 feet of welded joints and thousands of precisely fitted rivets, Kaiser saw an automobile, a complex machine broken into simple, repeatable components. He'd watched Ford's assembly lines produce cars in hours that previously took weeks. He'd managed construction of 3 massive dams using prefabricated sections moved into place by giant cranes. Why couldn't a ship be built the same way? January 1941. Richmond, California. Kaiser purchased 142 acres of tidal mudflat on the eastern shore of San Francisco Bay. The site was worthless, marshy ground that flooded twice daily, no infrastructure, No workforce, no shipbuilding tradition. Perfect. He didn't want tradition. He wanted a blank canvas where nobody could tell him what was impossible. The Maritime Commission thought he was insane, building shipyards from scratch when established yards could barely meet existing demand. But Kaiser had something the established yards didn't: no preconceptions about how ships should be built. The shipyard rose from nothing in 63 days. Workers poured 35,000 cubic yards of concrete to create stable foundations strong enough to support 150-ton cranes. Massive gantry cranes were erected on rails that stretched the length of 4 football fields. 7 giant slipways faced the water, each one a production line where keels would be laid and hulls assembled. Behind the slipways, Kaiser created something revolutionary: a massive prefabrication area covering 20 acres where entire sections of ships could be built simultaneously, then moved to the ways for final assembly. It was Ford's assembly line translated to shipbuilding. Each section, bow assembly, stern sections, deck houses, engine rooms, cargo holds, could be built by specialized teams at ground level with proper lighting and stable footing. The skeptics watched with bemused interest. This wasn't shipbuilding, this was industrialized madness. Ships weren't assembled like automobiles. They were crafted by skilled artisans who understood the nuances of marine engineering, the rhythm of the sea, the traditions of centuries. Kaiser had hired thousands of workers with zero shipbuilding experience: farmers from Oklahoma, factory workers from Detroit, unemployed laborers from across the Midwest. Half of them had never seen the ocean. They didn't know what was impossible because nobody had told them yet. April 1941, Kaiser Shipyard. First shift. The transformation began with a single radical decision: welding instead of riveting. Traditional shipbuilders riveted steel plates together using a team of 4 skilled workers. A riveter held the pneumatic gun, a bucker backed the rivet with a heavy steel bar, and 2 assistants heated and positioned thousands of individual rivets. It was skilled labor refined over generations. Each rivet had to be heated to cherry red, positioned precisely, and hammered while hot. It took 6 months to train a competent riveter. A Liberty ship required over 200,000 rivets. Kaiser's engineers calculated a different equation. Welding required only 2 weeks of training for basic proficiency. A good welder could join steel plates in a continuous seam that was actually stronger than riveted connections. The welds consumed less steel and weighed 600 tons less per ship than riveted joints. Critical factors when every pound of cargo capacity mattered. But welding had a reputation problem. The established shipbuilding community considered welded ships inferior, weaker, more prone to catastrophic failure, unsuitable for ocean service. They weren't entirely wrong. Welded joints, if done improperly, could crack under stress. The technique required precision temperature control and quality materials that weren't readily available in 1941. Kaiser didn't care about reputation. He cared about mathematics. One riveting team could install perhaps 300 rivets in an 8-hour shift. A Liberty ship required over 200,000 rivets. Do the math. That's 667 shifts for a single riveting team, or 2,000 man-days of labor just for riveting. One skilled welder could complete the same structural work in 400 hours, 50 8-hour shifts. The labor savings were 97.5%. The economics were irresistible. Train 10 welders in 2 weeks or train 1 riveter in 6 months. The decision wasn't difficult, but it required solving a problem nobody had confronted before. How do you train 15,000 people to weld to maritime standards in a matter of weeks? How do you maintain quality control when your workforce is 90% inexperienced? How do you convince the Maritime Commission that welded ships won't fall apart in the North Atlantic? May 1941. Kaiser Training Center. Richmond. The assembly line demanded assembly line workers. Kaiser created the first industrial training program designed specifically for welding, a crash course that could take someone who'd never held a torch and make them productive in 14 days. The program was ruthlessly efficient. Day 1. Basic torch operation and safety equipment. Week 1. Practice welds on scrap steel plates, learning to maintain consistent speed and temperature. Week 2. Real ship sections under supervision, with every weld inspected by certified welders. Graduate or wash out, there was no middle ground. The secret was modular specialization. Instead of training workers to weld entire ships, Kaiser trained them to perform one specific type of weld. Overhead welds, vertical seams, horizontal joints. Each worker became expert at their single task, then repeated it thousands of times. Muscle memory replaced years of experience. By June, the training center was processing 200 new welders every week. By September, 500. By December 1941, when Pearl Harbor transformed everything, Kaiser was training 1,000 welders weekly. The skeptics said quality would suffer. Kaiser said inspect everything and let the results speak. But skilled labor was only one piece of the puzzle. The ships themselves had to be redesigned for mass production. Every custom component, every hand-fitted piece, every unique measurement was an enemy of efficiency. July 1941. Kaiser Engineering Office. The British Ocean-class design called for 75 different thicknesses of steel plate, a nightmare for procurement and inventory management. Every thickness required separate orders, separate suppliers, separate storage. Kaiser's engineers simplified it to 27 thicknesses. The ships were slightly heavier, slightly less optimized, but infinitely easier to build. The original design included hundreds of custom-fitted components, each one requiring individual measurement and cutting. Kaiser redesigned them into standardized modules that could be pre-manufactured and assembled like building blocks. Ductwork came in standard lengths. Electrical panels were identical across all ships. Pipe assemblies were prefabricated in standard configurations. The revolutionary innovation was the prefabrication system. Traditional shipbuilding assembled everything on the slipway. Workers built the ship piece by piece where it sat. Kaiser built ship sections in massive fabrication sheds, then used giant cranes to lift entire sections, some weighing 150 tons, onto the hull for final assembly. The sections were enormous, entire bow assemblies complete with anchor chains and windlass machinery. Complete deckhouses with all interior spaces finished. Engine rooms with triple expansion steam engines already installed and tested. Cargo holds pre-fitted with ventilation systems, lighting and drainage. Workers in the fabrication sheds could work at ground level, with proper lighting and stable footing. They weren't climbing scaffolding or welding overhead in confined spaces. They weren't fighting weather, tides, or the motion of partially completed hulls. The sections moved through the fabrication area on rails, like automobiles through a Ford plant. When a section was complete, one of the massive cranes lifted it onto a ship hull in minutes. Workers on the slipway just welded the sections together and sealed the joints. A process that traditionally took months now took days. What had been craft became manufacturing. September 27, 1941. Liberty Fleet Day. The SS Patrick Henry slid down the ways at the Bethlehem Fairfield shipyard in Baltimore, the first emergency cargo vessel, later christened a Liberty ship. President Franklin Roosevelt attended the launch, giving a speech that inadvertently created the ship's lasting name. "This new class of ship will bring liberty to Europe," Roosevelt declared, echoing Patrick Henry's famous Revolutionary War speech. The name stuck, Liberty ships. But Roosevelt also called them dreadful-looking objects, and he wasn't wrong. The ships were brutally utilitarian, no elegant lines, no aesthetic considerations, just steel boxes designed to float and carry cargo. Time magazine dubbed them ugly ducklings. The Patrick Henry took 244 days to build, 8 months from keel laying to launch. It was respectable by traditional standards, but nowhere near fast enough for wartime needs. German submarines were sinking ships faster than that. Kaiser watched the launch and knew his Richmond yard had to do better. Much better. December 7th, 1941. Pearl Harbor, Hawaii. The attack transformed American industry overnight. Suddenly, the impossible was mandatory. The Maritime Commission's initial order for 200 emergency cargo vessels exploded to 1,600, then 2,000. Eventually, 2,710 Liberty ships would be ordered, a production run unprecedented in maritime history. More ships than had been built in the entire previous decade, more tonnage than the combined merchant fleets of most nations. The order represented 29 million tons of cargo capacity. Kaiser's Richmond Yard became the model for the entire program. By January 1942, his first ship, the SS Ocean Vanguard, slid down the ways after just 150 days of construction, still too slow. His engineers went back to the blueprints, finding more efficiencies. Every delay was analyzed, every bottleneck was documented. Every worker suggestion was considered. Kaiser offered cash bonuses for ideas that saved time. The yard became a laboratory for industrial efficiency. February 1942, Richmond Shipyard No. 2. The second yard opened with 6 more slipways and twice the prefabrication capacity. Kaiser had learned from the first 3 months of production. Every delay, every bottleneck, every inefficiency was documented and solved. The second yard incorporated all those lessons from day one. The key was concurrent construction. Instead of building ships sequentially, finish one, start another, Kaiser built them simultaneously. 7 ships at different stages of completion occupied the slipways at any given time. Meanwhile, sections for another dozen ships were being prefabricated. The yard operated like a pipeline, material in one end, finished ships out the other. The logistics were staggering. A single Liberty ship required 7,300 tons of steel plates and structural members, 250 tons of pipes and valves, 60 tons of electrical wire and fixtures, 150 miles of welding rod, 3 triple expansion steam engines producing 2,500 horsepower. Multiply that by 7 ships under construction simultaneously, and Kaiser needed a supply chain that could deliver 51,100 tons of steel, 1,150 tons of pipe, and 420 tons of wire every 3 weeks. The numbers were almost incomprehensible. No shipyard had ever attempted construction at this scale. He solved it through vertical integration. Kaiser didn't just build ships, he created the entire industrial ecosystem needed to support them. He opened steel mills specifically to produce ship plate. He established fabrication plants that produced nothing but standardized ship components. He convinced engine manufacturers to dedicate entire production lines to the simple, reliable triple expansion steam engines that powered every Liberty ship. When suppliers couldn't meet demand, Kaiser became the supplier. He built a cement factory to produce concrete for shipyard foundations. He operated quarries to supply aggregate. He even manufactured the tools his workers used. April 1942, Richmond, second shift. The workforce was unlike anything American industry had seen. By mid-1942, Kaiser employed over 30,000 people in Richmond alone. At peak production in 1943, that number would reach 90,000 across all Kaiser shipyards. More people than lived in many American cities. Half were women. Wendy the welder became the symbol of female shipyard workers, the shipbuilding equivalent of Rosie the riveter, who worked in aircraft factories. Janet Doyle, a welder at Kaiser Richmond, became the face of the movement. The government tried to promote Wendy with the same vigor they'd promoted Rosie, but the name never achieved the same cultural penetration. Still, the women came by the thousands. Women proved to be exceptional welders. Supervisors noted their attention to detail, and steady hands produced cleaner, more reliable welds than many male workers. The work required finesse, not brute strength. It required patience and precision, traditionally feminine skills suddenly valued in heavy industry. Training time remained 2 weeks. Anna Miller, an African-American welder, helped build the SS George Washington Carver in record time, less than 1 month from keel to launch. On May 7, 1943, Lena Horne christened the Carver, the second Liberty ship named for an African-American. Kaiser's recruiters didn't ask about race or gender. They asked one question: can you learn? The work was brutal. Welders wore leather jackets, heavy gloves, and darkened masks to protect against the ultraviolet light and white-hot metal. The masks had small windows of darkened glass that made it nearly impossible to see anything except the weld itself. Workers operated by feel as much as sight. Overhead welding, joining plates above your head while molten steel dripped around you, was particularly hazardous. First and second-degree burns were common. The fumes from welding contained heavy metals, manganese, chromium, nickel, that caused long-term health issues nobody understood at the time. Arc eye, inflammation of the cornea from UV exposure, sent workers to medical tents every day. Evelyn Spencer worked the graveyard shift at San Pedro Shipyard, welding aircraft carrier decks after spending her days caring for an infant. She earned $2 per hour, good money in 1942, equivalent to about $35 in modern dollars, but earned through backbreaking labor in conditions that would horrify modern safety inspectors. She wore steel-toed boots stuffed with newspaper because they didn't make women's safety shoes. She tied her hair back with scarves to keep it from being caught by sparks. The yards operated 24 hours a day in 3 8-hour shifts. There was no downtime, no maintenance windows, no holidays. Christmas, Thanksgiving, Easter. The ships were built through them all. Ships had to be built, and built now. The U-boats didn't take holidays. September 1942, Richmond, Shipyard Number 2. The competition between Kaiser's yards drove innovation through sheer competitive pride. Kaiser believed workers responded to challenges and recognition. He posted production times for each yard in massive letters visible across the entire facility. Richmond versus Portland. Which yard could build a ship faster? Which could launch more vessels in a month? The competition was real, and so were the rewards. Public recognition, media attention, even direct communication from President Roosevelt. Workers read their yard's achievements in newspapers, heard them on radio broadcasts. Their families knew which shipyard was winning. Pride became a manufacturing tool. The Richmond yards pulled ahead. By September 1942, they'd reduced construction time to 40 days per ship. 40 days from laying the keel to watching the completed vessel slide into the bay. It seemed impossible. 8 months to 40 days in just over a year. But Portland wasn't giving up. On September 23, 1942, the Oregon shipyard launched the SS Joseph N. Teal after just 10 days of construction. 10 days. The achievement made headlines across America. Workers in Portland celebrated in the streets. President Roosevelt attended the launch in secret. The visit couldn't be publicized due to wartime security concerns, but FDR wanted to see the miracle firsthand. His daughter Anna Boettiger christened the ship while her father watched American industrial power rewrite the rules of manufacturing. Roosevelt returned to Washington convinced that America would win the production war. Richmond responded 2 months later with a record that would never be broken. November 8, 1942. Richmond Shipyard Number 2. The keel for the SS Robert E. Peary was laid on a Sunday morning. Workers swarmed over the slipway in carefully choreographed shifts. Every move had been planned, timed, rehearsed. This wasn't just building a ship, it was proving a point. Prefabricated sections arrived by rail every few hours. Bow assembly, complete with anchors and chain lockers. Stern sections with rudder post already installed. Deck house with all interior spaces finished. Engine room with the massive triple expansion engine bolted in place. Giant cranes lifted them into position with precision measured in inches. Welders sealed the joints in continuous perfect seams. Electricians connected pre-manufactured wiring harnesses. Plumbers joined the miles of pipes that would carry steam, water, and fuel. Painters followed immediately behind, coating everything with preservative paint. 4 days and 15.5 hours later, the SS Robert E. Peary slid into the water. The shipbuilding record that would never be broken. Newspapers across America ran the story on front pages. Radio announcers described it in breathless detail. Of course, it was a publicity stunt. Much of the final fitting-out work remained, installing lifeboats, completing interior spaces, testing systems, calibrating instruments. The ship wasn't truly ready for service, but the keel to launch time was real, and the message was clear. American industry could produce faster than the enemy could destroy. The mathematics of attrition warfare had shifted decisively. Germany was sinking ships, yes, but America was building them faster, much faster. November 1942, Kaiser production analysis. The Peary was an outlier, but the median production time told the real story. In 1942, the average Liberty ship took 105 days to build. By November 1943, peak production, that median had dropped to 39 days. Some yards were averaging 30 days. 30 days from keel to completed vessel ready for sea trials. 30 days to build something weighing 14,000 tons and stretching 441 feet. 30 days to fabricate, assemble and test a complex machine with 5 cargo holds, 3 boilers, a 2,500 horsepower engine, 60 tons of electrical systems, and accommodations for 44 crew members plus armed guards. The numbers were staggering. In January 1942, American shipyards launched 2 Liberty ships. By November 1943, they launched 128 in a single month. 18 shipyards across 3 coasts, all running at capacity. Every 3 days, somewhere in America, a new Liberty ship entered service. Kaiser's yards alone produced 1,490 ships during the war, 27% of all U.S. maritime commission vessels. That's 1 ship every 1.5 days for 4 straight years. 1 ship, complete and ready for sea, every 36 hours, from the moment America entered the war until Germany surrendered. The ships cost approximately $1.75 million each to build, roughly $30 million in modern dollars. For comparison, Germany's Type 7 U-boats cost about $3 million each in 1940s money. Each U-boat could sink perhaps 5 to 10 merchant vessels during its operational lifetime. The Americans were building ships faster and cheaper than the Germans could sink them. March 1943, North Atlantic, Convoy HX-229. The brutal mathematics of attrition warfare played out in freezing waters 600 miles south of Greenland. Convoy HX-229, 37 merchant ships carrying over 500,000 tons of cargo, steamed east toward Liverpool. Alongside it, separated by just 120 miles, Convoy SC-122 carried another 50 ships. German Admiral Karl Dönitz had positioned 40 U-boats in a patrol line across their expected route. The convoy system's weakness was geography. Every eastbound convoy had to pass through the same 800-mile stretch of ocean called the Greenland Air Gap, too far from land bases for aircraft coverage. perfect hunting ground for submarines. The U-boats found them on March 16, 1943. For 3 days, submarines attacked in coordinated wolfpack tactics. The SS William C. Gorgas, a Liberty ship carrying 8,000 tons of cargo, including 900 tons of TNT, took a torpedo just after midnight on March 11th. She sank in minutes, taking 58 crew members with her. Over 3 days, the Wolfpack sank 21 merchant ships, 141,000 tons of cargo lost, 372 men dead. It was the largest convoy battle of the Atlantic War. German propaganda called it the greatest victory of the U-boat campaign. The German Navy estimated at this rate they would strangle Allied shipping within 6 months. They were wrong. The 21 ships sank represented 1 week of American shipbuilding production. In the time it took to fight that convoy battle, American yards launched 30 new Liberty ships. For every ship sunk, 1.5 were built. The Germans were winning battles but losing the war of production. May 1943. Black May. The tide turned in a single month. May 1943 would be remembered as the crisis point of the Battle of the Atlantic, the month Germany lost the submarine war. Allied destroyers, escort carriers, and very long-range aircraft closed the Greenland air gap. Convoys no longer traveled unprotected. German U-boats sank 34 Allied ships in May 1943. Allied forces sank 43 U-boats, 25% of Germany's operational submarine fleet, in a single month. The loss rate was unsustainable. On May 24th, Admiral Dönitz ordered a temporary withdrawal from the North Atlantic. The U-boats would return, but they would never again achieve the dominance of early 1943. The production numbers told the story. In May 1943, American yards alone launched 128 Liberty ships, nearly 4 times the number of Allied ships sunk. British Commonwealth yards added another 100,000 tons of shipping. For every Allied ship sunk, 4 were launched. The mathematics were brutal and decisive, but Kaiser's miracle came with hidden costs that wouldn't become apparent until ships started breaking in half. January 1943, North Atlantic. Sous de Gransee. The SS Schenectady sat peacefully at dock in Portland, Oregon, having just completed successful sea trials. The water temperature hovered around 4 degrees C. The air was barely warmer. The ship was unloaded, sitting high in calm water. Without warning, a sound like a rifle shot echoed across the harbor. Workers on the dock watched in horror as a crack appeared on the Schenectady's deck, just aft of the bridge superstructure. The crack propagated at the speed of sound, through the deck, down both sides of the hull, through the bottom girders. In seconds, the ship had split nearly in 2, held together only by the bottom plates. The Schenectady was a T2 tanker, not technically a Liberty ship, but built using the same welding techniques and similar steel. The catastrophic failure was terrifying. The ship hadn't been loaded, hadn't encountered rough seas, hadn't experienced any unusual stress. It had simply cracked in half while sitting at the dock in calm water. Investigation teams swarmed the wreckage. What they discovered changed metallurgy forever and vindicated the old shipbuilders' skepticism about welded construction. The steel used in Liberty ship construction was low-grade mild steel, all that was available during wartime when high-quality alloys were reserved for armor plate and weapons. This steel had a critical weakness. It underwent a ductile to brittle transition at low temperatures. At normal temperatures, the steel was flexible, ductile. It could bend and deform under stress, absorbing energy without failing. But when temperatures dropped below roughly 4 degrees C, the molecular structure changed. The steel became brittle. It would crack rather than bend. Under stress, instead of deforming, it fractured. And in welded ships, those fractures could propagate catastrophically. The problem was exacerbated by welding itself. Welded joints created what engineers call continuous crack paths. In a riveted ship, a crack that formed would propagate only to the edge of a steel plate, then stop at the rivet hole. The discrete connection points acted as crack arresters. But in a welded ship, there were no interruptions. The steel was continuous across dozens of plates. A crack that started in one plate could run through the entire ship before encountering anything to stop it. Add square corners on cargo hatches, stress concentration points where force focused intensely, and you had a recipe for catastrophic failure. February 1943, Naval Architecture Review Board. 12 Liberty ships broke completely in half during the war. 3 of them sank immediately, taking their crews with them. The SS John P. Gaines, en route from Alaska to Seattle in November 1943, cracked amidships in frigid waters. 10 crew members died as the bow section sank. Hundreds more suffered serious cracks, deck fractures, hull cracks, structural failures that didn't fully split the ships but required emergency repairs. Some limped into port with visible cracks running the length of their decks. By 1947, approximately 60 ships, half of them Liberty vessels, required replacement of structural components due to fracture damage. The failures terrified the Maritime Commission. Were these ships fundamentally unsafe? Had the rush to production created floating death traps? Should production be stopped until the problem was solved? Constance Tipper, a British metallurgist, led the investigation into why ships were failing. She was one of the first women to study engineering at Cambridge and had spent decades studying crystal deformation in metals. Her research discovered the ductile to brittle transition temperature phenomenon. She developed the Tipper test to measure material toughness at different temperatures, a test still used today in materials science. Her work established that 90% of the steel samples from failed Liberty ships had transition temperatures above 7 degrees. That meant the steel would become brittle in any cold water, not just Arctic conditions, but normal North Atlantic temperatures from October through April. The solutions were implemented as quickly as possible without stopping production. Stopping production wasn't an option. The war couldn't wait for better steel. Engineers redesigned hatch corners, rounding them off and reinforcing them with curved steel straps to eliminate stress concentration points. Crack arresters, riveted straps welded across vulnerable areas, were installed to stop propagating cracks. The irony wasn't lost on anyone. Adding rivets to fix problems with welded construction. Steel mills improved their alloys, reducing sulfur and phosphorus content to lower the transition temperature. Welding standards were tightened, with more rigorous inspection protocols. Every weld on every ship was inspected. X-ray equipment checked for internal defects. Magnetic particle testing revealed surface cracks invisible to the eye. Inspectors rejected welds that didn't meet standards, forcing welders to cut them out and redo them. The fixes worked. After 1944, catastrophic failures dropped dramatically. Ships still cracked occasionally, but few broke completely apart. The knowledge gained from Liberty ship failures advanced the entire field of fracture mechanics. The understanding of ductile to brittle transition led to better materials for bridges, buildings, pressure vessels, nuclear reactors. Every major infrastructure project built after 1945 benefited from lessons learned in Liberty ship failures. Engineering programs added entire courses on fracture mechanics, but the failures highlighted a truth Kaiser's critics had been whispering all along. Cutting corners had consequences. The remarkable part is how few ships were actually lost to structural failure. Out of 2,710 Liberty ships built, only 19 were lost due to brittle fracture. Less than 1%. That means 99% of these rushed, simplified, welded by amateurs vessels performed exactly as designed in some of the most hostile conditions on Earth. They crossed the North Atlantic in winter storms with 60-foot waves. They steamed through tropical hurricanes. They survived near misses from torpedoes that buckled plates and strained hulls. June 6, 1944, Normandy, France. The SS Robert E. Peary, the famous four-day ship, approached Omaha Beach carrying men and equipment for the invasion. German artillery targeted every ship in the anchorage. Shells exploded in the water around the Peary, sending up geysers of water and shrapnel. The crew offloaded supplies while explosions rocked the ship. One shell hit 50 feet from the hull, close enough that the blast wave knocked men off their feet. The ship survived undamaged. The publicity stunt ship proved to be reliable and resilient. Over the next year, the Peary made multiple Atlantic crossings. She transported German POWs from North Africa to America. She continued shuttle service to Normandy throughout the summer of 1944, running back and forth between England and France. She carried cargo to the Pacific Theater. She served exactly as designed. Not elegantly, not perfectly, but effectively. That was the real story of Liberty ships. They weren't elegant, they weren't fast, they weren't built to last. The original design specifications called for a 5-year service life. They were emergency vessels, disposable tools built to serve a single purpose. But they did their job. They carried 75% of all cargo shipped overseas during the war. They transported 7 million tons of supplies to the Soviet Union through the Arctic convoys. They delivered the tanks, aircraft, ammunition, food, and fuel that enabled Allied armies to fight across 2 oceans and 3 continents. The numbers tell the story of industrial warfare won through production capacity. 2,110 Liberty ships built. Between 1941 and 1945, American shipyards produced 5,000 merchant vessels of all types. The Liberty ships accounted for 27% of all U.S. Maritime Commission wartime tonnage. German U-boats sank 200 Liberty ships to submarine attack, 7.4% of the total fleet. That's actually a lower loss rate than traditional merchant vessels. The Germans also destroyed 175 other Liberty ships through surface raiders, mines, and air attacks. Total wartime losses, 375 ships, or 13.8% of the fleet. That means 86.2% of Liberty ships survived the war. For vessels explicitly designed to be expendable, that's remarkable. For ships built in 30 to 40 days by workers with 2 weeks of training, it's extraordinary. Some Liberty ships were still sailing 30 years after the war ended, long past their designed 5-year lifespan. Many were sold for commercial service and served in merchant fleets until the 1970s. Others were stored in reserve fleets, anchored in quiet bays, maintained in preservation, ready to be activated if another war came. By the 1960s, most were finally scrapped, cut apart for steel that would be recycled into new ships, buildings, cars. The steel that once carried hope across submarine-infested waters became the infrastructure of peacetime. Today, only 2 fully restored Liberty ships remain. The SS Jeremiah O'Brien, moored in San Francisco, participated in the 50th anniversary D-Day ceremonies in 1994, the only Liberty ship to return to Normandy. The SS John W. Brown, docked in Baltimore, serves as a floating museum and occasionally steams on demonstration voyages. Both are maintained by volunteers, many of them former shipyard workers or merchant mariners who sailed aboard Liberty ships during the war. They preserve not just vessels, but memory. The memory of when America transformed itself into the arsenal of democracy through sheer industrial will. July 1943, Pacific Theater, New Guinea. While Liberty ships dominated headlines for their Atlantic convoys, another fleet fought a different war in the Pacific. The SS John Burke approached Sansapor, New Guinea. loaded with 5,000 tons of ammunition, aerial bombs, depth charges, artillery shells. She anchored in Oro Bay on July 28, 1943, beginning the dangerous process of offloading explosives. A Japanese bomber appeared at dawn. The crew manned their defensive guns. Liberty ships in the Pacific carried heavier armament than their Atlantic counterparts. But one bomber got through. A single bomb hit the Burke's cargo hold. The explosion was visible for 50 miles. The Burke disintegrated instantly, leaving nothing but a crater in the ocean floor and a mushroom cloud rising 3,000 feet. The blast sank 2 nearby ships and damaged another dozen. Not a single crew member survived. The Pacific War demanded different tactics. Ships traveled in smaller convoys or independently, racing between island bases. Speed mattered more than defensive firepower. The 11-knot Liberty ships were too slow for some Pacific operations, but they served a critical role, establishing supply lines to newly captured islands. The SS Richard Hovey delivered the first supplies to Guadalcanal after its capture. The SS Thomas Nelson ferried construction equipment to build airfields on Saipan. The SS Stephen Hopkins became the only American merchant vessel to sink a German surface raider in single combat, trading fatal damage for a Pyrrhic victory that saved the convoy. Pacific Liberty ships faced different enemies. Kamikaze aircraft replaced U-boats. Tropical heat corroded metal and machinery. Typhoons with 150-mile-per-hour winds tested hull strength more than North Atlantic gales. The SS John A. Poor survived a direct typhoon hit that bent her deck and twisted her hull, but she made it to port under her own power. December 1944, Arctic Convoy JW-63. The Arctic convoys to the Soviet Union represented the most dangerous route of the war. Ships traveled around the northern coast of Norway, through waters where the sun never rose in winter and never set in summer. German air bases in Norway could strike convoys throughout their journey. U-boats operated from ice-protected fjords. The weather itself was an enemy. Water temperature in the Arctic was 2 degrees, below freezing but kept liquid by salt content. Any sailor who went overboard had perhaps 5 minutes before hypothermia became fatal. Ice formed on superstructures, sometimes weighing hundreds of tons and destabilizing ships. Crew members chipped ice constantly just to keep vessels upright. The SS Richard Bland joined Arctic Convoy JW-63 in December 1944. She carried 8,000 tons of ammunition, tanks, aircraft, and supplies destined for the Soviet Union. The convoy fought off U-boat and air attacks for 12 days. 3 ships were sunk, but the Bland survived, delivering her cargo to Murmansk. Arctic Liberty ships achieved something remarkable. Despite sailing through the most hostile waters on Earth, their loss rate was actually lower than Atlantic convoys. Better escort protection, improved anti-submarine tactics, and overwhelming Allied air superiority by 1944 meant Arctic convoys, while terrifying, were actually safer than they'd been in 1942. The Soviet Union received 7 million tons of supplies via Arctic convoys: food, fuel, locomotives, aircraft, tanks, trucks. Liberty ships carried most of it. Without those supplies, Soviet armies might have stalled or collapsed. Stalin publicly thanked Allied merchant mariners, calling them heroes of the Soviet Union. March 1945, Okinawa Campaign. The SS Logan Victory, a victory ship, the improved successor to Liberty ships, supported the invasion of Okinawa. But dozens of Liberty ships participated, carrying fuel, ammunition, food, and medical supplies. The SS Hobbs Victory took a kamikaze hit that killed 11 crew members but didn't sink the ship. Merchant mariners in the Pacific faced a grim reality. They had higher casualty rates than any branch of the US military, except the Marines. The Merchant Marine suffered a 1 in 26 mortality rate during the war. By comparison, the Army suffered 1 in 40, the Navy 1 in 114. Liberty ship crews received no military benefits, no veteran status, no recognition as combatants. They were civilian contractors, paid by the voyage. If their ship sank, their pay stopped the moment they hit the water. Many sailors survived torpedo attacks only to face bankruptcy because their wages stopped when the ship went down. It wasn't until 1988, 43 years after the war ended, that Congress finally granted merchant mariners veteran status. By then, most were dead. The belated recognition came too late for the men who'd sailed through submarine-infested waters, carrying the supplies that won the war. August 1945, Pacific Fleet anchorage. The atomic bombings of Hiroshima and Nagasaki ended the war suddenly. Dozens of Liberty ships, loaded with invasion supplies for Operation Downfall, the planned invasion of Japan, never sailed. The invasion fleet was vast, 14,000 ships and landing craft scheduled to participate. Liberty ships would have formed the supply backbone. Instead, they became occupation transports. Liberty ships carried occupation troops to Japan, food to feed starving populations, medical supplies to treat wounded civilians and POWs. They became cargo vessels again, but now carrying peace instead of war. September 1945, Richmond, California. The last Liberty ship, the SS Albert M. Bow, slid down the ways at the California Shipbuilding Corporation. The war was over, the emergency was finished, the impossible production run had been completed. Henry J. Kaiser became a national hero during the war. Public polls in 1945 named him the American civilian who had done the most to help win the war. In 1946, another poll listed him as a strong presidential candidate. President Roosevelt had even considered naming Kaiser as his running mate for the 1944 elections. He never ran for office, but his influence shaped American industry for decades. After the war, Kaiser applied his mass production techniques to automobiles, founding Kaiser Frazer and later Kaiser Motors. The first Kaiser car rolled off the assembly line in 1946, incorporating lessons from shipbuilding, modular construction, standardized parts, assembly line efficiency. He established Kaiser Aluminum in 1946, using wartime aluminum production facilities. Kaiser Steel followed in 1948, turning shipyard steel mills into a major American steel producer. He built homes, hospitals, and entire communities using prefabrication techniques developed for Liberty ships. He created Kaiser Permanente, the first prepaid healthcare system in America, initially designed to provide medical care for his shipyard workers. The healthcare system he created to serve 90,000 employees now serves 12 million people. The medical innovation was as revolutionary as his shipbuilding. 1946-1960, the Reserve Fleet years. After the war, 2,277 Liberty ships survived, 84% of those built. The Maritime Commission faced a question: what to do with the largest merchant fleet in human history? Scrapping them all would flood the steel market and devastate ship-breaking communities. Keeping them active would bankrupt commercial shipping lines. The solution was the National Defense Reserve Fleet. Thousands of ships were anchored in quiet bays across America: Suisun Bay in California, James River in Virginia, Beaumont in Texas. They were cocooned against corrosion, their engines preserved, their systems maintained just enough to permit reactivation. The ships sat in silent rows, waiting for wars that might never come. During the Korean War, 540 Liberty ships were reactivated. They carried supplies to Korea, proving that vessels designed for a 5-year lifespan could serve 15 years after construction. During Vietnam, dozens more Liberty ships returned to service, but by 1970 the fleet was obsolete. Modern container ships carried more cargo faster. New designs incorporated lessons learned from Liberty ship failures: better steel, advanced welding, improved hull designs. The old workhorses were finally sent to scrapyards. 1963, 1975, the scrapping. Shipbreaking became its own industry. Massive cutting torches reduced Liberty ships to steel scrap. The metal that once carried hope across submarine-infested waters became cars, buildings, bridges. Some ships were sunk as artificial reefs. The SS Theodore Parker rests in 50 feet of water off Fort Macon, North Carolina, now home to thousands of fish and visited by divers. Others met stranger fates. Several Liberty ships became floating storage facilities for surplus grain. One became a floating restaurant. Another served as a prison ship. The SS Polyus became a fish cannery ship, processing salmon in Alaska. A few Liberty ships found their way into commercial service around the world. Greek shipping companies bought dozens, operating them in the Mediterranean until the 1980s. One Liberty ship carried cargo into the 1990s, 50 years after being built for a 5-year lifespan. The SS Benjamin Warner became a floating museum in Greece, preserving maritime history. The SS Hellas Liberty serves as the only Liberty ship museum outside the United States. She sits in Piraeus, a reminder of American industrial capacity that helped liberate Europe. Today, only 2 fully restored Liberty ships remain in operation. The SS Jeremiah O'Brien, moored in San Francisco, participated in the 50th anniversary D-Day ceremonies in 1994, the only Liberty ship to return to Normandy. She steamed across the Atlantic under her own power, proving that 50-year-old vessels built in 30 days could still cross oceans. The SS John W. Brown, docked in Baltimore, serves as a floating museum and occasionally steams on demonstration voyages. Both are maintained by volunteers, many of them former shipyard workers or merchant mariners who sailed aboard Liberty ships during the war. They preserve not just vessels, but memory, the memory of when America transformed itself into the arsenal of democracy through sheer industrial will. The technical legacy. Liberty ship innovations transformed multiple industries. Welding techniques developed for rapid ship production became standard in construction, aerospace, and automotive manufacturing. The prefabrication methods created entire industries: mobile homes, modular construction, kit houses. Quality control systems developed to inspect thousands of welds became models for manufacturing inspection across all industries. Statistical process control, monitoring production to maintain quality, emerged from Liberty ship construction. The training programs became templates for rapid workforce development. Fracture mechanics advanced dramatically due to Liberty ship failures. Understanding ductile to brittle transition temperatures saved countless lives in later decades. Modern building codes require steel that resists brittle fracture. Bridges, pressure vessels, pipelines, nuclear reactors all benefit from knowledge gained at the cost of 19 ships and dozens of lives. The National Bureau of Standards established material testing protocols because of Liberty ship failures. The American Welding Society codified welding standards that prevented future catastrophes. Engineering programs added courses on materials science and fracture mechanics. Universities studied Liberty ship construction for decades. Harvard Business School analyzed Kaiser's management techniques. MIT examined the production efficiency. Engineering schools dissected the failures to teach better design. The production philosophy legacy. Kaiser proved that traditional manufacturing wisdom could be overturned. "That's how we've always done it," became recognized as the enemy of progress. His approach, measure everything, question everything, optimize everything, became the foundation of modern manufacturing management. Just-in-time delivery systems originated in Liberty ship component scheduling. Continuous improvement methodologies emerged from yard competition. Worker empowerment programs traced roots to Kaiser's bonus systems. Japanese manufacturing, particularly Toyota's production system, incorporated lessons from Kaiser's shipyards. After the war, Japanese industrial observers studied American wartime production. They saw Liberty ships as proof that quality and speed weren't mutually exclusive. The Toyota production system, developed in the 1950s, echoed Kaiser's modular assembly and continuous improvement. Modern shipbuilding owes everything to Liberty ship innovation. Every major shipyard worldwide uses modular construction. Ship sections are built in covered facilities, then assembled on ways. Welding is standard. Riveting virtually disappeared from shipbuilding by 1960. Container ships, bulk carriers, tankers, all use techniques pioneered for Liberty ships. The economics remain the same: build faster, build cheaper, build in quantity. South Korean shipyards that dominate modern construction use assembly lines directly descended from Kaiser's Richmond yards. But his lasting legacy was proving that industrial production could be reimagined. The shipbuilding establishment said 6 months per vessel was the minimum. Kaiser said 39 days and backed it with 1,490 ships. The experts said welding was unsuitable for ocean-going vessels. Kaiser said 99% success rate and let the math speak for itself. The irony is that Kaiser's radical methods became standard practice. Modern shipbuilding uses modular prefabrication, welding instead of riveting, and assembly line techniques, all innovations that the industry initially rejected. Every major shipyard in the world now builds vessels the way Kaiser built Liberty ships in 1942. The prefabrication techniques developed for Liberty ships were applied to construction, creating the mobile home and prefab housing industries. The welding methods were refined for building skyscrapers, bridges, and offshore oil platforms. The training programs became models for rapid workforce development across industries. Kaiser stood in the same shipyard where he'd started 4 years earlier. The mudflat was now the most productive shipyard complex in human history. The workers who'd been told they couldn't do it had built 1,490 ships. They'd proven that American industrial capacity, properly organized and motivated, could outproduce any force on Earth. The skeptics had been right about one thing: the ships were ugly, they were slow, they were built with shortcuts and compromises. But they floated, they carried cargo, and they helped win the war. In the end, that was the only metric that mattered. Not elegance or tradition or the approval of experts. Just tonnage delivered, supplies landed, troops supported. The brutal mathematics of industrial warfare, solved through the simple expedient of building ships faster than the enemy could sink them. The Liberty fleet wasn't unsinkable, but 86% survived the war because they were produced in such overwhelming numbers that losing 375 ships barely dented the fleet. They overwhelmed the enemy through sheer industrial capacity, quantity as its own quality. The plaque at the Rosie the Riveter Memorial in Richmond's Marina Bay carries a quote from one of those workers. "You must tell your children, putting modesty aside, that without us, without women, there would have been no spring in 1945. She was right. Without the workers, men and women, experienced and untrained, young and old, every race and background, there would have been no Liberty ships. Without Liberty ships, there would have been no way to supply the Allied armies. Without supplies, there would have been no invasion of Europe, no liberation of occupied territories, no end to the war in 1945. The ships were the bridge between American production and Allied victory. They were the physical manifestation of industrial democracy defeating industrial tyranny. The experts said it couldn't be done. The workers proved them wrong 2,010 times. And in proving them wrong, they changed not just shipbuilding, but the very concept of what American industry could accomplish when the survival of civilization hung in the balance. The Liberty ships weren't just vessels. They were proof that impossibility is just a failure of imagination, and that ordinary people, given the tools and the training and the motivation, can accomplish extraordinary things. That legacy outlasted the ships themselves, ships themselves, ships themselves, ships themselves, ships themselves, ships themselves, ships themselves,